Recorded. All right. Welcome, everybody. I'm sure a few other people are going to kind of file in as we go along here, but excited today to have Shelly Blake-Plock is here to speak with us today about documenting the total learning architecture, or the TLA, an account of the work of the TLA Study Group. So if you're not familiar with TLA, I'm sure Shelly's going to share a little bit about that with us as we get going here today. But I'll just share a tiny bit about Shelly. He is the chair of the TLA Study Group, and he has been an officer of the IEEE LTSC since 2018. Shelly, you may have to remind me what LTSC stands for as well. I'm sure there's several people here who do, but lots of acronyms here. And he was also the chair of the ISICLE, which stands for the International Consortium, the charter chair of ISICLE, the International Consortium of Learning Engineering, for Learning Engineering. He is co-founder and CEO of Yet Analytics, developer of the open source SQL LRS. So I'm gonna, without further ado, I'm gonna pass it over to Shelly so that he can share with us everything that he has brought to share today.
Great, thank you. I'm going to share my screen.
Yep. We can see it.
All right, can you see the full screen slideshow?
Yes, we can.
Okay, great. So thanks for having me. A couple things about what we'll chat about today. This is going to be a talk about the total learning architecture and a group at the IEEE that is working on a book about this subject. So a couple things just to start. The IEEE, if you're not familiar, is the largest professional technical association in the world with over 500,000 members. And it is the IEEE Standards Association that is responsible for standards that affect many technologies that you use every day, including things like Wi-Fi. Within the IEEE, there is an organization called the Learning Technology Standards Committee, or LTSC. That committee is responsible for the standards activity, which creates global standards related to data, software, and processes in the learning space across all domains of learning, from K-12 through corporate, higher ed, military, government, etc. So the total learning architecture, as we'll see here when we get into it. So this is an idea that was originally developed a decade ago by ADL, Advanced Distributed Learning at the United States Department of Defense, which is now Advanced Digital Learning. And the idea was, well, first of all, a lot of you probably know ADL as the shepherd of the XAPI data specification. Around 2016, ADL got the notion to expand the interoperability scope from existing standards such as SCORM for LMS content, the old LOM, or Learning Object Metadata, standard for course identification, and XAPI itself. Expand that into sort of a full view of the entire enterprise learning ecosystem. And so 4 data domains were established. The first was learning metadata, which is defined by a standard of the IEEE called 2881. All IEEE standards are 4 numerals and sometimes addition numerals after that. But I'll describe as we go forward. Learning metadata, as we'll see, is about the ability to describe learning experiences. Learning activity, which is the 9274 suite at IEEE. This is XAPI, and the ability to semantically define learning activity and then communicate that learning activity in a verifiable way. Learning competencies. This is IEEE 1484.20 series. And learning competencies are the what domains of understanding, what levels of proficiency are ascertained by the activity that occurs. And last, learning records, defined by P2997. This standard is currently under development and defines the roll-up of all of the data collected into learning records at the organizational or enterprise level. I'll get far deeper into all of this. This slide is just meant to say, when we're talking about the TLA, there are 4 pillars to the TLA: metadata, activity, competencies, and records. If, as we go through here, anyone has any questions, please put them in the chat. And if folks from Torrance want to ask me any questions that come up, feel free, because I have a feeling that some questions may come up. So part 1, TLA alignment. So we're going to specifically look at those 4 data domains and how they're defined in standards and then represented in software. So the 4 layers themselves, we start with the 2 data preparation layers, and they are our metadata that we described. And the purpose of metadata is to provide context. If you think about if you upload a video to YouTube, you might say that that video that you uploaded is about baseball. And specifically, you might put a tag that it is a Little League baseball game. And then specifically, you might put a tag that it is a Little League baseball game that occurred at nighttime. A Little League baseball game that occurred during with one of these teams involved. So you can add metadata to a video on YouTube to provide context. This is the same idea applied to any learning experience. So the role within the TLA is that in the same way that we use tags on something like YouTube to be able to discover things when we search for them more easily, if I search for Little League videos, something tagged with Little League videos will pop up. Same thing here. This ensures discoverability, it adds context, and it's machine readable. You'll find that all of the TLA standards are machine readable, which means that we can provide software that validates conformance against the data models within each standard and can operationalize the data standards into something that can be used in a business. Associated standards are this Learning Object Metadata Standard 2881, and the type of software that validates the standard and provides access to it is called an experience index. And we'll talk about each of these 4 pieces of software as we move on through the presentation. The second piece of the data preparation layer is learning activity. This tracks the activity that occurs during a learning experience. The role is to validate, store, and provide access to learning activity data based on standardized data statement and data profile formats. Many of you will be familiar with this as XAPI and XAPI profiles. And we use learning record stores and XAPI profile servers to validate this data. I should note here that when people hear the term learning record store, because there are such a variety of things that have been done with these in the commercial marketplace, they may think of like dashboards and learning analytic systems and all this sort of thing, which none of that is core to what a learning record store does. All of that is added on by vendors or different projects in the space. The core job of a learning record store is to validate that the data is XAPI, to store the data, and provide access to it. If your machine is doing that, it's an LRS. And you'll find that with the software that we're talking about, the primary function of each piece of software is to validate that the data follows the model of the data standard. So then we move from the data preparation layer into a business intelligence layer. And what we're talking about there are the next set of pillars in the TLA. So competencies. Competencies assert state. Now, when I say that, a lot of people have a lot of assumptions about what competencies are and what competency engines do. I simplify it this way. I say that I'm not going to make any claims about the competencies. I'm not going to make any claims about what proficiencies mean. What I'm going to say is that the purpose of the data standards and the usage of competencies within the TLA is to define the state of the learner at a given point in time in relation to however competencies and proficiencies are described by an organization. In other words, the standard does not define what the competency means to an organization. The standard defines that the competency exists in a specific format and that the implementation of that format means that a certain state has been described in terms of the pathway of the learner. So this asserts the learner's state in relation to those defined competencies. Depending on the organization that is using this, it may be KSAs, proficiencies, stress levels, difficulty levels, etc. Shareable competency definitions are defined by the TLA, and competency frameworks and assertion engines of all varieties that import and implement the shareable competency definitions, sometimes called SCDs. They are the pieces of software that both do the work, but also are validating things against the SCD data format. They're expecting things to arrive in that format. Learning records is the final part of the TLA. This records the state. So if a competency engine asserts that a learner has reached a certain state, think about this in terms of just like something simple like levels, 1, 2, 3, 4, 5, 5 being the highest. We may assert that a learner is at level 4. That state then is recorded in the enterprise learner record repository. And when later that state changes, say the learner graduates from proficiency level 4 to proficiency level 5, the state can be sent to the learner record repository, and the state of the learner record will be updated to reflect the new situation. Likewise, if we have something like a certification and a learner is required to update the certification every year, we may record for 1 year that the current state is that the certification has been completed. In the following year, it may be that the learner did not complete the certification, in which case what could be recorded to the record store, the record repository, is that now the state is that the learner is out of compliance. So this is information about the learner It's housed by an organization. The 2997 data standard controls this within the TLA. And the piece of software is called an Enterprise Learner Record Repository, or ELRR. Now, some of these pieces of software you've seen widely in the commercial market, particularly learning record stores and competency assertion engines. The things that might be new to you are the experience index and the ELRR. To date, the only ELRR that is in production with the current state of the data standard is the one that is being developed at ADL. So there are no commercial ELRRs in the market for two reasons. First, the data standard is not finished. Therefore, anything purporting to be an ELRR could not be, because it doesn't have anything to validate it against, because the model is not finished. And second, the work on the API that communicates things back and forth between the ELRR is also being defined by IEEE, and it is not completed. So that's just a buyer beware out in the market, that fourth pillar is currently under very intense design presently as we speak. Okay, I want to look at each of these pillars more carefully and talk about them. So metadata about learning experience across modalities. This is core to the idea of learning metadata in the TLA. Traditionally, if you go back to the way that metadata was handled in learning technologies, it usually had something to do with the concept of a course. And this came out of like courses being represented within LMSs. And therefore, the metadata might tell you about the name of the course or the instructor. The problem that ADL recognized is that as soon as you open up beyond formal courses into learning experience more broadly, which could include things like micro mobile learning or learning that happens informally out on a publicly available LXP that someone can get a badge from and then bring it back to the organization. Or in the case of simulations, where someone may be doing something in virtual reality or a hybrid simulation that is wholly, it might be described in an LMS, but it's wholly separate from the LMS. Well, what that means is that now we need metadata that describes not just the course that occurs within the LMS itself, but we need metadata that represents all of the type of activity that can happen across learning experiences. That is the goal of the TLA as it pertains to metadata. So I might say things like the metadata that I am adding to this learning experience says things like, okay, this is the topic, this is the course, this is the information that would be covered in this learning experience, but also here's the modality, right? Maybe I'm doing this in a traditional e-learning environment. Maybe I'm doing it in a hybrid simulation environment. Maybe I'm doing it via augmented reality or through informal learning. This is the modality. This is the type of instruction that might be involved. It may be project-based, it may be performance-based, it may be assessed by a traditional multiple choice, it may be assessed through essays or the delivery of a portfolio. All of those different types of aspects that describe better what the learning experience is, what it means, how it's delivered, what its modality is, and how it might be assessed, all of that can be included in the metadata. So when I'm searching through a large course catalog, trying to understand what courses may be available to me, either as a learner or an instructor, I can see not just the topics that are available, but I can see if I prefer teaching something in virtual reality, I can find out what assets are available to me in virtual reality. If my style of teaching is project-based learning, I can see what assets are available to me to teach via project-based learning. That's the idea here. It's a much richer discoverability. So the XI, the experience index, is the software. And what the software does, this is a metadata repository. It validates the meta tags against the structure dictated by the IEEE data standard, and then makes them available to course catalogs, instructional design systems, authoring platforms, etc. Okay, next up, just a side note. I'm going to show you some schematics over the course of the next half hour. These are just meant as an illustration. Actual implementations of the TLA can vary widely. We see that the two most important things are that when leveraging the data models, they include verification of the data model and we don't stray from it. That ensures interoperability across the ecosystem. And second, they are not including anything into the system that would break the interoperability between the core pillars of the TLA itself. So we're going to look at data coming out of course catalog, data coming out of a learning record provider. This might be a LMS that sends XAPI data, and a simulation. And in our case, the simulation is going to send data via an XAPI-enabled intelligent tutor that manages the simulation. So that's the three places for the purpose of our representation that we can pull data from. So we start with our sources. We've got the experience index and an enterprise course catalog. From a learner point of view or from an instructor point of view, I can look in the course catalog to find the experiences that are available to me. Those experiences are tagged with metadata from the experience index. Then we have a record provider, such as an LMS, and we have a simulation, as I described. The simulation is going to send its activity through an AI broker, and that AI broker will be doing two things. It's going to be translating the learning activity that occurs in the simulation into XAPI and sending that downstream. And it's going to be taking things like telemetry data, or if you're familiar with simulations, things like open disk data or high-level architecture data, and it's going to be passing that on to a data lake. All right, so then we have linked data out of the web, which we'll come to shortly. And we have a portal that our learner can access the course catalog. All of these yellow boxes represent producers of data. They are all controlled by the first two of our pillars, right? The metadata pillar and the learning activity pillar. So let's take a look at that learning activity pillar. This is where we track activity. So standardized activity in the form of structured XAPI. This provides two things: syntactic integration between components in an ecosystem, and semantic interoperability for the purpose of machines and human analysts understanding what data means in different parts of the system. Rather than rely on a controlled vocabulary, XAPI is flexible. So vocabularies can be created to define novel learning experiences. And what we do is we use XAPI profiles to create models of those activities. Way to think about it is like I can describe a basketball game, and I can say that a player shot the ball. Well, that's an XAPI statement. Player shot the ball. I could say that the player shot a foul shot. That's also an XAPI statement. And it gives a little bit more definition, right? Now we know that didn't just shoot a ball. The context was that this was a foul shot. That's all handled in XAPI. When we start to string XAPI together, for example, to talk about all of the possible things that can happen in a basketball game, passing the ball, shooting the ball, rebounding the ball, scoring points, getting a technical foul, etc. All of the activity that can occur within a game, all of that activity needs to be described in a model. And that model is called an XAPI profile. We'll talk about more about that in a moment. So as we said, an LRS validates the XAPI data, profile validators that live within profile servers and as middleware in other systems provide validation against the XAPI profiles. So we ensure that we're working with clear, standardized, expected data. Okay, now I talked about that already. When we look at our schema, let's add in these XAPI validation components. So first, the LRP, in this case, we're going to say it's an LMS, is emitting XAPI to a learning record store. In the TLA, we don't have one learning record store. In fact, I would say that one of the biggest challenges for teams, both of learning engineers and IT folks to grok, is that the LRS is not one thing. There's not a monolithic LRS. In other words, we're sort of used to the idea of having like a monolithic LMS. We have one LMS, everything goes into it. And we think, therefore, all the records from the LMS go into one LRS and we're done. That's not actually the way the TLA works. The TLA is going to send data from different systems, different regions, different domains into different LRSs. And those LRSs are charged with different purposes. First, they do the core things that all LRSs are supposed to do. They validate, store, and make the data accessible. Okay? But we call these noisy LRSs. And the reason for this is because the data from these noisy LRSs can be filtered via what we refer to as XAPI profile filters into what we call a transactional LRS. So let's just walk through the schema real quick because it's useful. All of the data that we're collecting from our LMS, all that XAPI lands in an LRS. All of the XAPI data that we're collecting from our simulation lands in another LRS. There we have two big buckets of data. There are two different types of data, one representing activity in the LMS, one representing activity in the simulation. From there, we use patterns within an XAPI profile to filter the data that we want that aligns to business needs down into what we call a transactional LRS. One of the things that people often gloss over in discussion of XAPI profiles is this concept of patterns. While it's true that XAPI profiles provide a way to essentially create a registry of verbs and activities and objects, what we call concepts in XAPI profile speak, there's more to it than that. Because we take those concepts and then we can say there are specific sequences of activity or there are specific types of relationships between activities that have business model use case significance. So I could say, if these activities happen in a certain sequence, that aligns with a certain business model. Therefore, when we see the sequence happen, I can use this profile filter to send that sequence to the transactional LRS. So out of all of the data that we've collected in the noisy LRSs, I can filter out the exact data that aligns to my business model in the transactional LRS. I'll come back to that with any questions because if you're hearing that for the first time, that might be tricky. Okay, so going forward. The third pillar, learning competencies. So, like we said, these are start state. Shareable competency definitions are machine-readable. These are definitions that include not just saying like, say that our competency is leadership. Well, within leadership, we may actually have a number of specific meanings within our organization. So there may be specific KSAs associated with demonstrating leadership. There may be specific proficiency levels of leadership that you gather over time. All of these can be contained within what we call rubrics within a shareable competency definition, so that when we implement them, as people go through proficiency levels or as they tick off KSAs, you can see that they're attaining competency, rather than sort of an older concept that just said stamped competency, move on to the next node. All right, so it's more granular, and all of those attainments can be tied directly back to activity that you're tracking via XAPI. All right, so different competency engines are going to process all sorts of data, not just XAPI. They may pull in demographic data. They may pull in telemetry data. But when we're talking specifically about the learning activity, what learning took place in the experience, in the TLA, the expectation is that that's going to be delivered via XAPI. And therefore, any competency assertion engine that's used with TLA data should be expected to be able to consume XAPI from a learning record store. All right. Okay, so we plug in our competency pieces here in blue, competency registry framework and competency assertion engine, right? Now, what happens next? Well, next is our last part, the learning records. The enterprise learning record is the roll-up of the data across everything. One way to think about this, it's not an exact science. And like I said, this standard is not finished. It's currently under development, and the software is currently under development at ADL. But think of it by analogy as like an electronic health record, where if I go to my primary care physician, they might want to share information with the pharmacy. They might want to share information with a specialist. I go to the specialist, and they might want to share information because I'm going to have a procedure done. So they share it with the hospital, and the hospital shares certain information with an insurance company, and the pharmacy then gets information. So everyone gets pieces of information that they need to do their job out of my total electronic health record. It's a similar idea to that there are going to be pieces of an organization that need different information about my background, my training, my learning record, my proficiencies, my mission readiness, that can pull that information together from an enterprise learning record repository. Traditionally, that data is siloed. Like if you go to any large enterprise, you'll have, an L&D department might have certain data. Your training instructors may have certain data. Your talent management people have certain data. Your readiness or workforce planning department has certain data. Your financial people have certain data. Here, the idea is that there could be a single repository that then has permissions to be accessed by people across the organization. And this is the thing that's kind of amazing, and the moonshot is that not only could they be shared within the organization, but in the same way that your doctor can send information to the pharmacy and your specialist can send information to the hospital, your workplace might want to send information to a channel partner, or your place of education may want to send information to a new job that you're going after. So in the same way, there can be shared information, not just within the organization, but across different organizations. That's the moonshot under development. All right, so let's start to bring this all together. The enterprise learning record creates the end of our schema. And now from yellow, where data starts, through purple, where data is validated and processed into business information, into blue, where it is asserted as competency and proficiencies and capabilities, to green, where it lives as the current state of the learner. This schema represents the total learning architecture. Okay, quick takeaways. A, there's alignment between domain standards and validation software. If you don't have one of those things, you don't have the TLA. People can say that they do something like the TLA. They're perfectly welcome to do that, but don't expect it to be interoperable. The point of the TLA in the schema that we just saw is that all of the data going forwards and going backwards is entirely traceable, explainable, and interoperable. Next, each data domain represents a role of data within the TLA, right? There are multiple roles for data. Think about the data you're collecting, not just by the metrics that you're trying to figure out, but by the role that different data represent. The standards ensure interoperability. Data validation is the integral job of the components. So you can have the flashiest LRS on Earth. You can have the flashiest competency assertion engine on Earth. Good for you. That's awesome. Make sure that it can actually do the job of validating the data against the data standards. Because if it can not do that, it can have all the bells and whistles, but you're not going to be able to show interoperable data, and you're not implementing the TLA correctly. All right, part two. Jumping into these standards. So the learning metadata standard, as we said, is the shared vocabulary around the way we tag. Just like you tag things on YouTube, you can tag metadata in a learning experience. It could be about core properties about the experience, things about educational contexts. It enables search and discovery. It describes interaction within competency frameworks, right? Maybe in my competency framework, I can now see that I have certain types of content or certain types of performance activity that relate better to the demonstration of a competency than other things. It describes relationships between activities. And these metadata are based on RDF. So there are learning objects, learning resources, learning events. All right. Most of you know about XAPI. XAPI is a RESTful type of web service defined in JSON. It's validated and stored in an LRS. It's flexible. It's interoperable. It was approved by IEEE back in 2023. The statement components. You have an actor, Bob. You have a verb, shot. You have an object, the basketball. You have the context. It was a foul shot. You have the result. It went through the hoop. You have the timestamp. It happened with 3 minutes remaining in the game. That is the core to an XAPI statement. That's what's there. That's what's available to you. It also gives you the authority of who did it. The NBA, in this case, stamped it. And this is what it looks like. So in this case, we have my colleague over at Yet Analytics, Cliff, who attended a standards brief via WebEx at this time. We have XAPI profiles. Okay. So in the same way that XAPI describes discrete activities, XAPI profiles describes conglomerations of activities. If XAPI describes an activity discretely, XAPI profiles bring them all together, many XAPI statements, and describe experiences. So they define the vocabulary. We call this concepts. They create schema for individual XAPI statements. We actually make templates of what statements should look like within a profile. We share the behaviors of how groups of these statements work together and can either broaden or narrow the context. I like to think that the most important thing is XAPI profiles is when you move from just collecting data into collecting data in a way and in a format using a model that is relevant to your business interest. The components are concepts. These are verbs, activity types, and extensions. Templates, so you can create a template of what the statement should look like. Patterns, as we said before, can be sequences. They can be alternates where we like branch out. They can also be optional. Did someone do or choose not to follow a pattern? And they can be 1 to 0 or more, meaning I can do one pattern, I can do no patterns, or I can do more than one patterns, collections of patterns over time. They can get as complex for the purposes of conditional logic as your business systems need. And this is what they look like. So at the top, we have a concept. That concept is a presentation. The presentation is a type of activity, right? And then below that, we say that within the context, well, what's the context of this presentation? It has to do with an extension that is going to say that I attended this presentation. So I attended the presentation. This is my template up top. And if you're not getting all of this, don't worry about it. This is great for the nerds in the room. For anyone who doesn't know what they're looking at here, just understand that this is the way that the machine is reading the description that someone attended something. And the takeaway is that attendance and what it means, this is all represented in the XAPI profile. The pattern, very simple pattern here, right? If you look at the last 2 lines, it says attended and then completed. So in order to complete this pattern, I had to attend the conference, and by attending the conference, I completed my task. Okay. Now you can imagine that you could make those, you could extrapolate and build out all kinds of branches, all kinds of things. I've certainly seen profiles that existed in a few hundred lines of code. I've seen profiles that existed in over 50,000 lines of code. So there's great variety, and this should be defined by what your business use case is. Okay, shareable competency definitions. These are machine-readable formats of the definitions for the competencies. They define the competencies, they account for the context, they tell you what's required to attain them, so they have those rubrics, and they define relationships between competencies. For example, we might say that this is a sub-competency, and you must attain it prior to getting the macro competency. They're in JSON LD format. The standard is published by IEEE. We call these SCDs. They contain the definitions, competency frameworks, associated objects, rubrics, the rubric criterion levels. So I might have one rubric that says, this is the criterion to hit proficiency level 1 versus 2, 3, 4, 5. And then 4th, the enterprise learner records. I apologize on behalf of the entire IEEE community that we have ELRs, LERs, and ILRs, and they are 3 completely different things. All right. LERs are learner employment records. That's something wholly different. Don't worry about that right now. ILRs are individual learner records. They got sort of subsumed by what became LERs. Don't worry about that right now. We can have a long cocktail conversation about that later. What we're concerned about right now is just ELRs. So it's data model for recording the roll-up of the information about the learner. It aggregates from XAPI activity. It stores learner competency and current state. It shares, it stores the contextual information, like demographic information, like where did I go to school? Who is my current employer, et cetera. The standard is under development. The objects in the standard: person, who the learner is; the organization, who is their school, who is their employer; the learning record itself; their military or employment records that may be relevant; competency attainment and status, either through educational institutions, informal learning, or on the job; credential attainment and status. I'm an accountant. Every year I have to get my credential updated. I have to take CEUs. Did I do it? And contact information for everyone involved. That's what's in the ELR. So let's talk about putting it all together in our remaining 5 minutes here. So we talked about how these yellow boxes are our sources. They're sharing information that's validated by the XAPI resources. The information in those resources then is passed into our business layer, where it's going to live in a transactional LRS. That business-ready data is shared with the competency assertion engine, which is tied to our competency framework. Information from that competency assertion engine is then shared upstream to the enterprise learner record repository. All of this is accessible by learners, instructors, administrators, whoever has permissions to look at different parts of the system. And then we have backend services that provide security, DevSecOps, and continuous integration of the entire learning ecosystem. This is the TLA. In the real world, things get crazy, okay? They leverage and adhere to the data standards and validation mechanisms. But I always like to tell people there is a difference between adhering to a technical standard and implementing a solution. And I've never seen two TLA implementations that are the same, because implementation should be driven by business use case, business need. Okay. To the benefit of the TLA, everything in the TLA is modular. So if you go back all the way to the beginning of the presentation and you just have those four core pillars, I have metadata, I have activity, I have competencies, and I have records. So long as you're working with those in the validated mechanisms that IEEE provides you with, you can say that you're working with TLA. I'll give you an example. This is a real world example, came out of research at the Army that was published back in 2022. I had the pleasure of working on this for 3 years in a project called Steel R, which was the synthetic training environment, experiential learning records. So we start with a synthetic environment. In this case, it's a use case where we have multiple inputs during the learning experience, desktop, headset, and some advanced hybrid simulations. Information is sent, therefore, multimodally from the synthetic environment. Some of that gets passed, especially like telemetry data and things like this, gets held downstream right off the bat. We had an intelligent tutor that actually managed the activity that took place in the synthetic training. This was an AI-enabled intelligent tutor that could pass XAPI data about what people were doing in the learning activity onto a learning record store. So that went to the noisy LRS. Then we used a profile filter, as described before, to pull out we didn't want to deal with all of the data that was being collected because it was a ton of data. We wanted to make it more economical, more cost efficient, faster. So we filtered out exclusively the data that we needed for our business case, and we sent that to a transactional LRS. The information in transactional LRS was used by a competency assertion engine to assert competency, which was then passed up in real time to a dashboard. The goal of the project was from number 1 to number 9, everything could happen in real time. So as people were doing the activity in the learning experience, their proficiency levels and where they were in terms of assertion of competency was being tracked on a mission control dashboard in real time. Sort of like a video game, right? Where you're getting the stats while you're playing the game, except in real life. Here's another example for data pre-processing purposes. So we have an XAPI stream from an LMS plugin. Then we've got a different XAPI stream from a mobile app. Then we've got sim activity, and some of that issues XAPI. So I'm going to send things from my LMS to a noisy LRS. I'm going to send things from my mobile stream to a noisy LRS. I'm going to send things from my sim activity to a translator to another noisy LRS. So now I have 3 LRSs representing 3 different pools of XAPI data. I'm going to filter all of that data through a number of different profile filters. And I'm going to take the business-ready data and send it to a transactional LRS. From there, I'm going to assert my competencies. I'm going to pass that on to recording dashboards. But I have another use for the information that's in that transactional LRS. I'm going to use that combined with my assertions to update my ELRR. And I'm going to use my ELRR in combination with all of the transactional data that I've collected to feed a training system for AI and machine learning. This was where my processing is going to happen. So in this use case, unlike the last one, instead of the purpose being to track competencies and get a mission control dashboard, here I'm using the TLA as a pre-processing layer to prepare learning data for AI training. So in addition to this portfolio, the LTSC has standards on ethical design of AI and adaptive instructional systems, the learner records, SCORM, and data governance. You're all welcome, if you haven't before, to join any of the LTSC events. All IEEE Standards Association events and calls are open to the public, and all of the standards activity is done by consensus in a public forum. For more information about any of this, feel free to contact me directly. We do have about 5 minutes, and I'm happy to take any questions that people have. Oh, you know what? I almost forgot. So, what I wanted to make sure to talk about. So I gave you, this is like, so I gave you all of that. That's all the setup, and here's the punchline. Okay. So 55 minutes of setup, and it goes here. This is the book that we're writing. So we have over 100 contributors who are all working together in what's called the TLA Study Group to take everything that we just talked about and put together a book-length report about this. This report will be published by the IEEE. You can see that it covers everything that we talked about: XAPI, definitions, metadata, learner records. And what we want to do is use this report to help the IEEE decide on next steps in the next generation of learning data standards. Is there a place for TLA data standards to guide the next generation of learning products? That's up for debate, and it's the work that we're doing within this group. We have a monthly meeting, which I can share details of in the chat. You're all welcome to. And there are 6 or 7 different subcommittees, each working on different chapters in the book. We're about halfway through. The book is slated to be delivered in December of 2026. Now, I'm open for questions. How do you do that? Anybody?
We've had a couple of people asked for the link to this Steele, our research paper. I think both Matt and Ruben found either a version of that or a portion of that and popped that into the chat already.
If you look over, there are a bunch of them. I'm actually going to just point you to my bibliography because I've got like 5 or 6 of them over there. If you go over to the link that I just shared and look through last year and like the prior 3 years, there are a bunch of research papers, several of which were delivered at ITSEC.
Great, thank you, Shelly. I know that if people don't have questions, it's probably just that they're taking it all in, and
yeah,
you shared a lot of information, which
it is a lot.
Yeah, yeah. I know I personally was very familiar with some pieces of what you shared. And there were new and different parts for me that I was not as aware of, as I haven't been as plugged into LTSC.
Understood. If you're new to this, and you're on the call, the big takeaway for you should be that when someone talks about the TLA, think about those 4 core pillars, right? Metadata, activity, competency, records. And you can think of the TLA as a next generation way to bring all of those together into one place, make sure that they're interoperable. And if we're successful, and many of us on the TLA have been working on this for over a decade, if we're successful on this, we could help to create a new generation of learning technologies that is far more centered on learner outcomes, is far more transparent, is far more interoperable.
Yeah, I especially appreciate along the way, the focus on, several times you mentioned, making it relevant for your business and your business outcomes that you need. And so, keeping that kind of at the center or top of mind, that it's not just hey, just plug into this new LMS and it'll do whiz bang everything you need. You have to define what you need, and by building to that, you will ultimately, have a business case for everything you're doing versus.
Absolutely. Matt asked a question: have you seen any real interest in developing commercial software outside of the government use cases? Yes. Neither. This is part of the problem with the TLA, honestly, is that this is a case where, because of the open source nature, it's actually easier to talk about government use cases than it is to talk about what's happening in industry. I can think of two implementations in the tens of millions currently within large industry commercially in the US, that I can't describe to you at all because of the nature of disclosures with working with commercial business. So apologies for that, but that's the reality in the space right now.
Yeah.
All right. If anyone wants to get in touch or needs to get in touch with me, I just put my email in the chat. If you're interested in the TLA Study Group, let me know. We have another year ahead of us working on it. If you're interested in getting involved in LTSC standards, let me know. If you're interested in any of the software components, I want to learn more about how these things work, reach out.
Excellent. I'm just going to wrap us up. We'll have a recording of this session. We'll put it up. We have a repository, torranceLearning.com/lit/library. So you can go see stuff there. And then just a quick peek at what is coming ahead. So we have, this is actually the conclusion of our LIT series for this fall. Some of you may have seen a message that went out about this party is lit and doing an in-person event this fall. We did need to postpone that, so we are still planning to do a lit party, but it's going to be in the spring instead. So if this all kicks off, we're going to do kind of a similar structure to how we did this fall. We're going to have a lit lab, 3-week hackathon type of experience, which kicks off on February 5th. You can check your inboxes for more information about that. We'll then have some lit a different series of Lit Spotlight sessions starting in March. And then in May, we're going to have this Party is Lit, which will be an in-person event. I believe we'll still be in Troy, Michigan in May. So keep your eyes out for all of that. If you had signed up previously and you're receiving emails from us, from the Lit team, we have then you will hear about all of this stuff when this rolls out. If you somehow found us through LinkedIn or somewhere else and you haven't signed up on our mailing list, you can go to torranceLearning.com/lit and there's a form to fill out there. But if you're already receiving emails, no need to go there and check that out. So that is all I have today. Thank you so much, Shelly. I appreciate you coming and sharing with us what the current state of the TLA is, and look forward to seeing what is to come with that in the future.